long period oscillation, or also is also called phugoid motion, right? It's part of the dynamic stability. It's a part of the longitudinal dynamic stability. So last class we had drawn one diagram, and with that diagram we have to get the result related to phugoid, like what is the time period, because you had seen it is the long period oscillation. So oscillation is there, it means definitely natural frequency will be there, time period will be there, and that oscillation, how it is going to damp or how it is going to get its initial condition. So obviously damping should be there. Okay, last class I had explained nicely like what is the damping and how it will damp and what is the required in oscillation, when it will be stable, when it will not be stable, that all discussion we have done. So here we have to keep in our mind, like for the long period oscillation, for the phugoid, we are going to derive the natural frequency for the phugoid, and that was asked in exam also, GATE exam. All right. So see, we have to check. This is the now airplane, and this airplane obviously it's a initial condition. So uh, so weight is mg, and we can take lift is nothing but L naught. This is the one condition which is also called steady trim condition. And this airplane is now on the horizontal reference, and now this airplane is what following the path, and it is just going to gain some altitude, because in case of the phugoid motion, I told you that kinetic energy will be converting in potential energy, and potential energy will be converting into kinetic energy. It means there is the exchange of energy. That definition we had seen last lecture. So now this airplane is what now gain the altitude. You just say for this airplane, you just simply say from the horizontal reference, this altitude is nothing but h. This altitude is nothing but h, and obviously now this velocity will be v here. This velocity will be v here, and perpendicular to velocity we have lift L now, and obviously that weight will be continuously working downside is mg downside. Okay, and we have a flight path angle from the horizontal reference. Flight path angle is what? Theta. Remember, theta is horizontal, theta is the flight path angle, it's not an angle of attack. That discussion we already have done in last lecture. Okay, now so these two condition we have. One is what? Airplane is what reached at some height, so here you can have potential energy, because your this is your reference line. Okay, from this is your reference, so from the reference height is what h it is gained. I can write here horizontal datum better. This is the horizontal datum. Datum is the, in the sense it's a reference, a line. And now this airplane is what? At steady trim condition. Trim means I already explained. Trim in the sense equilibrium condition, means lift is equal to weight, thrust is equal to drag. That is the steady state condition. All right. Now for this particular we have some assumption, so we need to make note of this assumption. And remember, in longitudinal dynamic stability, phugoid is very important. Whenever question will be asked, it will be related to the phugoid. Okay, so just focus on phugoid motion and you will get your all concept here. Okay, assumptions. Now number one, what is the assumption? 3 4 important assumption I want to mention here. Like the aircraft is what? Initially in steady level flight. Okay, so aircraft initially in steady and level flight. Number one. Number two, the total energy of the aircraft remains constant. Okay, the total energy of aircraft remains constant. What is the mean of it? The total energy means kinetic energy plus potential energy is what? Constant. That's the mean of it. Okay, it's constant. Number two. Number three, I want to mention here that incidence angle or angle of attack. Okay, angle of attack remains constant. Remains constant, and already I had explained for the phugoid motion angle of attack will be constant, okay, but for the short period oscillation angle of attack will be continuously changing, but for the phugoid means long period oscillation we have a constant angle of attack, alpha will be constant. And these are the three assumptions here I have mentioned. Now based on this, now you have to focus, because if you see this diagram, particular this diagram, so for this, whatever the steady trim condition we have, if you check whatever energy is what containing by this plane, the total energy for this plane and this plane will be same, because we have mentioned here that total energy of the aircraft is what remain constant. If I say total energy, it means kinetic energy plus potential energy. So whatever the kinetic energy and potential energy for this plane is equal to kinetic energy and potential energy of this plane. That is our main motive for the point 2, assumption 2. It means total energy for the plane in both points at steady trim and at some altitude, both plane will have the same total energy. So we can write for this first, we can say, we can mention here, uh, we can mention here for both condition condition of airplane, total energy must be constant, okay. Meaning is the energy at point 1, here I mentioned this is the point 1 and this is the point 2, okay. So in both points the total energy must be constant. Here we can say kinetic energy plus potential energy at point 1 for the airplane is equal to kinetic energy plus potential energy at point 2 for the airplane, okay. So what is the potential energy at point 1? Obviously 0. Why? Because it has not gained any altitude. If altitude is what gaining, then only potential energy will be there. But still that airplane is what moving with velocity, some velocity we can say, you can say this, because this lift is what L naught, so this velocity becomes V naught. Not property only, it is showing trim condition or steady level condition, okay, just like in turning flight. So if it is a steady flight, hence the lift will be L naught and velocity will be V naught. But once it is gain some altitude, so lift become L and obviously velocity become V. Anyway, so first point, we do not have any potential energy, only kinetic energy will be there. So what is the kinetic energy? We can say the mass of the airplane is what M and velocity is what V naught, so half mv square will be the kinetic energy for point 1, and at point 2 the kinetic energy will be half m, velocity becomes v square plus potential energy. What is the potential energy? It is because of the height. What is the height? It is gain h. So mgh is the potential energy, that you know. So this equation you need to remember, this is very important, okay. Even though question will be asked also, so for both 2 points you have to balance the total energy in case of phugoid. This is one thing. Now this is the one thing. And second point I want to tell you, like if you want to develop the relation between v naught and v, then how you will develop? It's a simple, that airplane is what suppose gaining altitude, so this is what our reference datum line, and now suppose this plane is what gain this altitude, this gain the altitude. What is the altitude? It is gain h. With what velocity? It is v. And when it was at horizontal condition, then what was the velocity? It was v naught. So means initial velocity was v naught and final velocity it becomes 1. So this is equation 1. And if you know, because it is gaining altitude, so it is against gravity. So if you write the equation of motion equation, so what you will get? The final velocity is equal to, or uh, final velocity is equal to, final velocity square is equal to initial velocity square v square minus, because it is against a gravity, so 2gs. This is the equation of motion, you all know this, okay. So final velocity is what? V square, when airplane is what gain at some altitude, is equal to initial velocity was v naught, you can check the diagram, and h is the height it is gained. So v square is equal to V naught square minus 2G. This two equation you got. Now each and every equation you please just try to connect, and automatically the final result you will able to, you will able to mix all equation, and finally will get the result. So nothing is what difficult here, nothing is what new thing, it's all basic equation only we have to use. Now this is the second one. Now if you check for the steady trim, for the steady trim condition, trim state, the lift force will be, what will be the lift force here? So if you check, LE is equal to, or LE, or I can say equilibrium, LE for the lift at equilibrium. Trim means equilibrium condition, okay? So what is the lift force? Obviously it is half rho v square, but at steady state, what is the velocity? It is v naught, so half rho v square. You can check here, at steady state means at this point, we are talking about this point. So this L naught will be the lift at the trim condition. So what will be the value here? Half rho v naught square, because velocity at steady state is nothing but v naught. So this LE, or you can say L naught, meaning will be same, so don't get confused. Half rho v naught square S into CL. This is what the lift force you will get. This is the equation number 3. And fourth, again statement I will write, because once airplane is what gains some altitude, so you can call it like this is what the trim state. So we can say at some height gained by airplane, then what will be the lift there? What will be the lift there? So obviously at that height L, lift will is nothing but half rho, velocity becomes v square SCL. This is the equation. Now this is equation number 4. Okay, all equation you have to summarize, means for both points 1 and 2 we are writing the lift force simply. Okay, now we have to check the value of equation. If you see, we have here v naught v square is equal to v naught square minus 2gh. Okay, now this equation, equation number 2, okay, this is equation number 2, and the equation number 3, what we have, equation number 2 and equation number 3. From this equation number 2, 3, 4, we can write equation 2, 3, 4. Okay, equation 2, 3 and 4, we have to relate this. Then what value we will get? Check, can we say from equation 2, we just try to connect so you will understand. See, v square, we had written equation 2, v square is equal to v naught square minus uh, what is that, 2gh, right? That is the equation of motion. This is the equation. Now see what we'll do here, simply both side, okay, simply both side we have to multiply, by half rho v square, uh, both sides. So we can multiply half rho v is already there, half rho, uh, we have to multiply half rho throughout the equation, half rho s into CL, because v square is already there, we have to multiply by this. So what this equation will be there, it will be half rho v square s CL, half rho v square s CL, minus half, 2 cancel out, so we'll have a rho g h s CL. This is equation number 5. Okay, this is equation number 5. Now we have to check here, we got half rho v square s CL, half rho v naught square s CL, minus it is rho g h CL s, rho g h SCl. Okay, this is the result now. Now check. You can get by your own. What is the value of half rho v square SCl? Half rho v SCl is nothing but L, right? So we can keep here L. What is this half rho v naught square SCl? It is nothing but L naught, or you can write Le, and this is nothing but rho g HSCl. Now instead of L naught, can we write L naught is equal to, because it's a steady state conditions. If there is the steady state conditions, so can we say lift is equal to weight? And what is the weight? Weight is nothing but mg, right? It is universal. You in performance subject you had seen at a steady state condition or equilibrium condition, lift is equal to weight. That you know very well. You just place that value simply. Okay. So here we can write this. Also we can write here mg. Okay, simple. At a steady state, lift is equal to weight. So this L naught will be replaced by mg minus rho g h s c l, and this is nothing but L. All right, this you got. Now again you have to check. This is the equation number 6. This is the equation number 6. Okay, you write it. L is equal to mg minus rho h s c l. Now for this particular diagram here, uh, if you go back and check this diagram, so in this case, if you see this value, basically theta is what given from the horizontal. Theta is what given from the horizontal. Okay, this value is given from the horizontal. Theta will be this one. If you check vertical value, so if this is theta, so definitely from the vertical this will also be theta. So this is nothing but what? L cos theta. So vertical lift force is nothing but L cos theta. Vertical component will be L cos theta, right? Now, so if you check the vertical component, which is nothing but L cos theta, also you can write, if you check the vertical force, inertial force, or as per Newton's law, you know, F is equal to what? Ma. F is equal to what? Ma. Now, M acceleration, you can write acceleration. Acceleration is nothing but dv by dt, right? Dv by dt, you know, or you can say M velocity becomes dx by dt. So dv by dt will be d square x by dt square. You might have seen many times in vibration, d square x by dt square. So basically d square x by dt square is nothing but acceleration. Okay, acceleration. But here we do not have x. What we have, in what dimension it is moving? In vertical direction. So our, instead of x, our height will be there, that is m d square h by dt square. This will be the equation, right? This will be the equation. Everybody should understand this. So inertial force, this is what, as per Newton's second law, inertial force we have, inertial force. And from where it comes? From Newton's second law. From Newton's second law, everybody knows Newton's second law. Everybody knows F is equal to ma. This is the inertial force. So that is mass into acceleration, and acceleration, you know, dv by dt you can write, or you can write d square x by dt square. In your graduation time, might you have done this, uh, you know, this type of manipulation. Dv by dt you can write d square x by dt square also. So this d square x by dt square is nothing but acceleration. X is the dimension in which you are moving. So generally we are moving in a horizontal direction, so we take x is the dimension where we are moving. But in our case, airplane is moving in vertical dimension, and vertical dimension here we had shown h. If you check the diagram, so we have seen here h. So that's the reason, instead of x you will place h. So it becomes m d square h by dt square. And that also, you know, this double derivative also you can write h double dot. Like this you can write mx double dot. In vibration you might have seen mx double dot. Double dot means 2 times derivative with respect to time. So in actual we have h, hence we have written mh double dot. That should be very clear. Now if you check the forces, so the our force as per Newton's law in vertical direction. So if you see the vertical direction force also, that is L cos theta. Okay, summation of force I am writing L cos theta, but weight is what, in just downward direction it is acting. So our F force, what is the F force resultant is nothing but L cos theta minus mg. This will be the resultant force. F becomes m h double dot L cos theta minus mg. We can write like this: for a small angle, for a small flight path angle, small theta. So what will be the cos theta? For a small theta, cos theta becomes 1, because theta is small, just like 0. So cos 0 becomes 1. So you also can write approximate L minus mg. Okay, you can write like this. You can write like this. This is the one thing. Now coming to the point, ultimately you got this equation: mh double dot is equal to L minus mg. This is the equation you got here. Okay, you got here. And okay, up to this you just converted. Now after equation 6, we can write, this is equation number 7. We can write equation number 7. So now this value you have to place, because L is equal to what you have got here, mg minus rho g HCl. So instead of mg, L minus instead of mg. Okay, or L value directly you place here. Sorry, you can place L directly, so it will be cancel out. You can place the value of L. So what is the L now from equation 6? It is mg minus, rho g h s into Cl, and this is mh double dot. And obviously from here minus mg, this minus mg will be there. So this mg will be cancelled out. No? This mg and this mg will be cancelled out, because here you have simply placed the value of h. Value of h you have placed here. A value of L you have placed here. So L is nothing but mg minus rho g HCl. If you check, this value will be cancelled out. Okay, so what you will get ultimately, you will have mh double dot and is equal to minus rho g h s, or you can write mh double dot plus rho g h s L is equal to 0, right? This value you will get. Those who have done vibration, they are getting completely, I know, because this type of equation we have to convert. We had converted in vibration subject, and ultimately we'll compare with our standard equation, then we'll get the natural frequency. Anyway, you can check this, because this is the function of h only, so you can keep rho d s cl inside bracket, and now it will be h is equal to 0. This equation is what I just want to remind your graduation days. In your graduation, you had written mx double dot plus kx is equal to 0. If I'm right, you can recall this and you may get it, mx double dot plus kx, and there you had calculated natural frequency. It was root k by m. This was the natural frequency, because this was the k and this was the m. M was the mass and k was the stiffness of the spring. Like that you had done in your graduation, right? Okay, so the similar equation you are getting here also, because in Phugoid we had seen oscillation will be there. If oscillation is there, by it means it, you can compare it from the vibration point of view. If oscillation there will be there, then there will be natural frequency as well as there will be time period. And because it is the damping oscillation, why I'm saying damping oscillation, damping means it is going to reduce the amplitude. And I explain you, if it is dynamically stable, then it should have a decrement in amplitude, and finally it should reach to its original position. So there should be damping. Okay, damping means the reduction of the amplitude continuously. All right. So first of all, I just want to compare this standard equation what you have. This is equation number 8. I can say this equation 8 is what the whole story behind this, what you have done till now. Because of this equation number 8, you wanted this equation number 8. That is the whole story actually. Equation number 8 is your final conclusion. Now you have to compare this. Then what you will get, what will be the mh double dot rho g scl h. H is the height, just like x is the distance in horizontal direction, similarly h is the distance in vertical direction. Okay, so it's like a displacement, better to say displacement, just like x is the displacement in horizontal direction. If you remember this type of the concept of the spring, this sorry, this was the spring mass system. If you remember this spring mass system, so you fix this spring here system, and you had a spring, and this was the mass m, right, and this was the k. If you apply the force f and just remove, then it becomes free vibration, and that time if you calculated what was the oscillation, it was through km. The simple concept we have here also. So now if you compare with this, so approximately what is the natural frequency? Next page I will move. Now you can write mh double dot plus this rho g h s, h you take outside, rho g s cl, rho g s cl into h, right, rho g s cl into h is equal to 0. Now if you compare by this natural frequency, so you will get, okay, you will get what you will get, what you can write this, you can write uh, you just h double dot plus, you can write rho g s cl by m mass into h is equal to 0. Now if you check this, this is nothing but h double dot plus, I can write this whole bracket value in natural frequency term. It is omega square p for phugoid, or ph I will write phugoid, h is equal to 0. So ultimately you can get this equation, uh, and if you now check this wph is nothing but natural frequency. This is very very important, and this they had asked in gate. Okay, so the whole work what we have done because of this equation. Now what is your wph? So wph is, I just want to write, it's nothing but natural frequency. It's a natural frequency, okay, or frequency or natural frequency, you can say natural frequency, or you can say phugoid frequency, phugoid frequency, okay, natural frequency, or you can say phugoid frequency. So what is this value now? So you can write here directly wph square. You have, you just compare from the standard equation, it is nothing but rho g, uh, why I am writing h again and again, rho g s, rho g s cl by m, right, this is the wph square, you have just replaced it. Okay, so what is the WPH? It is natural frequency, and it is nothing but root of rho G S CL by M. This is the natural frequency. Okay, this is the natural frequency of figured. Please remember, because a theory question nowadays they are asking very fantastic way they are asking, but if you focus and if you go through the analysis point of view, if you check last 4 year question paper, then all the theory question, if you know the basic formula behind the theory, then from the formula only you can answer for that theory. So that's the reason nowadays it is very important to crack theory question, you should know the formula. Now you can see the natural frequency point 1, the natural frequency ph is directly proportional to the density. Okay, it is directly proportional, natural frequency is directly proportional to obviously the wing area. Natural frequency is also directly proportional, because g we are taking constant, so I'm not going to write that, and wph is also directly proportional to cl. There is no doubt, it's all are in root. Okay, and very important point 4, wph is also inversely proportional to mass. If mass you are changing, mass of the airplane you are changing, then fluid motion frequency will be changing. So this is very important theory and question they are asking from here. Okay, this is the, up to here it is done. This is the one part, but it is not over now. Again we'll go for the next analysis for this wph. What we have here, check, it is, it is rho g s cl by mass. If you now connect with this, then any lift force, generally we take L naught value here, if you check what is the L naught, L naught is nothing but half rho v square SCL, half rho v square SCL. So if we want to replace this, then what we'll do? Then what we'll do? Also, uh, we can write one thing: L naught is equal to mg is equal to half rho v square SCL. This whole equation will write. Okay, so then it will be clear. We have L naught is equal to half rho v naught square SCL, and this L naught is also is equal to mg. Okay, so now you can check what is the rho SCL, rho SCL we have here. Then what is the rho SCL? If you check, we want to reduce this equation, then rho SCL will be what? 2 times of mg, 2 times of mg divided by rho SCL v naught square. This is the value. This is the value. Now you keep here. So what is the WPH? Uh, we have rho SCL. So G is already there. Rho SCL you can keep 2 mg, 2 mg, 2 mg divided by v naught square, and m is also there in denominator. Check everybody what I have done. I have simply taken rho SCL value from this equation. From this, L naught is equal to half rho v naught square SCL is equal to mg. So because L naught is equal to mg also is there. So from this equation, half rho v, I took this equation only, half rho v square SCL is equal to mg, and then I took rho SCL is equal to, what will be the rho SCL? It is mg 2 times of, because 2 is here, it will multiply 2 mg by v naught square, and this rho SCL will replace by 2 mg by v naught square. See, rho SCL we have, so G is already there. G keep, rho SCL will be replaced by 2 mg divided by v naught squares, and in denominator m is there. So this m will also be cancelled there. We just focus, it's just focus, okay, because question they are asking. So m cancel out now, and G square we have, and 2 we have in root. So obviously you can take G square, so out one root you can take, and v naught square, so root will be v naught out. Here you will have 2. This is very, very important. This is very, very important. What is the result you got? Natural frequency of natural frequency of the Phugoid motion is nothing but, you can write z root 2 divided by v naught. Okay, so this very important formula you keep in box and remember this. Okay, you can, because simple value they will give to you, and they can ask question, calculate the natural frequency of the Phugoid motion. So this story is not end up here. If you go for this particular, so you also know the time period. What is the time period? Because this is the natural frequency, and if you know for the time period, so what is the time period? T is nothing but T is nothing but time period, if you know. So it's always just reciprocal of the frequency, just reciprocal of the frequency. Time period is nothing but just reciprocal of frequency. But in terms of the angular velocity, if you go, so it is nothing but 2 pi by the omega, right? 2 pi by omega. This is the time period. Yes, this is the formula. T is equal to 2 pi. So the same thing whatever you have written here, this all points, it will just reverse for the time period. So for the time period also, question they are asking for it. Okay, your time period becomes 2 pi, and rest everything, w is nothing but just like here, if you keep, then this w will be what? Ph for the Phugoid. So 2 pi, it is what? G by root t v naught. You can write 2 pi v naught divided by uh, g root 2. If you check root 2, one cancel out, so what you will have? You will have a root 2 pi v naught by g. This is very special. This is the time period of Phugoid. Okay, time period of Phugoid, root 2 pi v naught divided by g. All right, everybody getting this or not, dear? Tell me.
हाँ सर.
Right. So this is what the time period for the Phugoid Again the same thing, I mean theory, if you keep all value in terms of this, uh, in terms of rho g hcl and m, in terms of time period also if you write, then it will be just reverse. Okay, so always remember, like I want to write here also, if you write for the tph time period, so it will be just reverse 1 by rho, like that only, because time period and angular velocity, just now here you have seen natural frequency, it is just opposite, yeah? So the every result will be just opposite only. Only tph, that time period of the phugoid will be directly proportional to f. Okay, that you need to remember, because for the natural frequency it is opposite, so obviously for time period it will be directly proportional, rest all will be just opposite, reciprocal. So this theory point of view, it is very important, and you need to remember. Okay, you need to remember this, because question they had asked based on it. Okay, question they had asked. Now this one is done, time period and natural frequency, which was very important, and if you check the question also they had asked based on it. And latest also, like theory based question they are asking, so I believe that if you remember such type of formula, so from the formula only you can answer for the theory question. Okay, it happens many times, and you can solve many questions, theory question, from the formula only if you know the result, right? So for the phugoid, this is the time period and natural frequency also you have written. One more thing I want to write, that is called the damping ratio. Damping ratio for the phugoid. Okay, damping ratio for phugoid motion. So this is again one more derivation, but here I will not derive. I will give the result to you, because this is another one more derivation, damping ratio for the phugoid. So you just write, this is the damping ratio of the phugoid pH, and this is nothing but, you can get 1 by root 2. It is nothing but CD by CL. This result you need to remember. Okay, this result you need to remember. Result you need to remember. So here also, if you check the damping ratio, which is what, directly proportional to the, depends on the drag. Okay, depends on the drag. Damping ratio always depends on the drag and lift. Okay, so by the formula only you can get here. So this three formula you need to remember. I have given wph also, which is natural frequency. I have given the time period also for the phugoid. Okay, so this is the thing, what was related to the figure I have done here. Any question if you have, ask me. Up to here, is there any question? In vibration, if you remember, damping ratio is what related to the time period of the vibration also. So from there we can write this zeta ph, which is the damping ratio 1 by root 2 cd by cl. Or also you can write it 1 by root 2. This also you can write d by l. Okay, cd by cl also you can write d by l also. There should not be any doubt. Okay, d by l. Is that clear? All right. So
Yes.
yes, so if drag is more and more, then damping ratio will be more and more, and that's the reason. That's the reason you can connect with the theory also. Damping ratio means what? See, I explained you damping ratio or damping. What is the damping basically? See, suppose oscillation is what is started. Okay, once disturbance comes and hit to the airplane, so that airplane will start oscillation like this. It will start oscillation like this. Okay, so I told you, if it is going to suppress, I mean amplitude is what, continuously decreasing, and finally it got initial point, because initial is here, and again it got initial. It means it is stable dynamically and statically, both it is stable. Why statically stable? Because static stable means initial tendency to come its original position. That is one. And what is the dynamic stable? It's related to the amplitude. Okay, it's related to the amplitude. And if amplitude is what, during the oscillation, if amplitude is what, converging means amplitude is what, continuously decreasing, then it is called dynamic stable. If oscillation is performing, means it have initial tendency to come back, but it is it is not converging, it is diverging, means amplitude is what continuously increasing, then it becomes dynamic unstable, dynamic unstable. But if it is converging oscillation, means converging oscillation means amplitude is what continuously decreasing, then you will say dynamic, it is stable. Okay, so that is the one thing. Now if you check in each and every cycle, that amplitude is what continuously decreasing, so that is called damping. That is called damping. Damp out of the oscillation means, damp out of the oscillation means immediately, or it will take certain time of period, but amplitude continuously it will be decreasing, 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 and it will get to its original position. So to analyze that, we will have damping ratio, damping coefficient or damping factor, or simply damping meaning is what, to reduce the amplitude. So related to the amplitude reduction, we have damping coefficient. Two types of damping coefficient we will have: natural damping coefficient, okay, natural damping coefficient, and the forced damping coefficient, or you can say critical damping coefficient. Critical damping coefficient, okay. That ratio of the damping coefficient, natural and critical damping coefficient, will give the damping ratio. Okay, so that is the vibration part. So that's the reason I am not going into that. But this damping ratio you need to remember, because this is required. And in examination they had all asked also. If you check one more question here, we can create by our own. If you see damping ratio, this formula you have derived here. Okay, this one you have derived, but at the same time, if you check this damping ratio of the phugoid, zeta ph is nothing but, you got here, it's a 1 by root 2 td by cl. This also you can write 1 by root 2 d by l. This also you can say is nothing but 1 by root 2 1 upon l by d. Okay, also you can say it is nothing but 1 by root 2 1 by e. What is the e? Is the aerodynamic efficiency. So this theory question also they can ask, our damping ratio is what, directly proportional to aerodynamic efficiency or inversely proportional. So yes, it is inversely proportional to aerodynamic. So this type of analysis theory for the theoretical question, if you know the formula, you can finish this. Okay, so hardly two lectures required for the different type of motion. Like in case of the lateral and directional both stability, we have a different type of motion, like a Dutch roll, a spiral roll, a spiral divergence. This type of motion we are having in case of the lateral and directional stability. So hardly 2-3 lectures required to complete this. Okay, today I have done damping. Today I have done pivot motion, and all damping process till here we have finished. Uh, Formula we have derived, and theoretical question like a spiral divergence or Dutch roll, we have to finish in 2-3 lectures. Then next subject, as I told you, math we are going to start. Okay, in this uh, week, end of week, we have to start. I had discussed to the faculty, and very soon they will fix the timing. Okay, they are having a timing issue, but they will fix the timing. Once it is fixed, then we'll do that. On Sunday, are you able